Hello everyone, I'm Mineta Liu Jianming. Today I will introduce method of bisection search and method of grid search. Here is the outline of my presentation. We go to the first part, method of bisection search. First, we need to know what is zero. Simply speaking, a zero is the solution of fx equals 0 for a given function f. Then comes the concept of method of bisection search. Bisection method in mathematics is a root-finding method that repeatedly bisects interval and then selects a subinterval in which a root must lie for further processing. To know it clearly, we need to know two theorems. First is intermediate value theorem. We see in this picture, if f is a continuous function defined on interval a to b, and k is any number between fa and fb, then there exists a number p in interval a to b, for which fp equals k. The second one is a corollary of the first one. If f is a continuous function defined on the interval a to b, with fa and fb of opposite sign, then there exists a number p in interval a to b for which fp equals 0. Compared with the first one, this one just let k equals 0 and we can get it. You should bear in mind that there are two key points. First, at least one number p, which means sometimes, maybe rarely, there are more than one p. Last, the method calls for repeated bisecting of subintervals of interval a to b, and at each step, locating the half containing p. Here are the main steps. To begin, set a1 equals a and b1 equals b. Let p1 be the midpoint of interval a to b and p be the root of fx equals 0. That is, p1 equals this value. Then we check the function value of p1. If fp1 equals 0, then we get what we want. Otherwise, if fp1 and fa1 have the same sign, p will be in interval p1 to b1. Then set a2 equals p1 and b2 equals b1. Or, if fp1 and fa1 have opposite signs, p will be in interval a1 to p1. Then set a2 equals a1 and b2 equals p1. Till now, we finish the first process, then reply the process to the interval a2 to b2. But when to stop it? We observe this stopping criteria. We suppose a tolerance epsilon. Epsilon is larger than 0, and generate this sequence until one of the following conditions is satisfied. The first one, the second one, and last one. Generally speaking, inequality 2 is most useful. We use two examples to explain this method. First, find the root of this function using bisection. To solve it, we check the function value when x equals 0, 1, 2, and 3. We find that when x equals 0, 1, and 2, the function value is less than 0. Where x equals 3, f3 is larger than 0. We can see that f2 plus f3 is less than 0. Hence, the root lies between 2 and 3. Here is the second example. Show that fx equals 0 has a 0 in interval 1 to 2 and use the bisection method to determine approximation to the root that is occurrent to at least within 10 to the power negative 4. Before solve it, we plot fx first. We can see around x equals 1.4, fx equals 0. Here are the specific solutions. First, we check if there is a zero. By calculation, we know that f1 is less than 0 and f2 is larger than 0. By AVT, we ensure that this continuous function has the 0 in interval 1 to 2. Then, for the first iteration, we have that f1.5 is larger than 0. This indicates that we should select the interval 1 to 1.5 for our second iteration. Then we find that f1.25 is less than 0. Continuing in this manner, we can get the following table. This table shows the 13 iterations. Then we use doping criteria to check it. We can see that this value is less than 10 to the power negative 4. So the approximation is correct to at least within 10 to the power negative 4. Hence, we approximate the root p using this value. Actually, the correct value of p is this value. In other words, our method is correct. Then we go to the second part, method of grid search. Besides method of bisection search, method of grid search is also a useful method. It involves setting up a suitable grid in the design space, evaluating the objective function at all the grid points, and finding the grid point corresponding to the lowest or highest function value. In a word, it evaluates the function value at each grid point to find the minimum or maximum. Also, it can find the solution of fx equals 0 by the relationship between these two equations. Their relationship can be written as follows. I believe all of us have learned it in mathematical class, hence, I will not mention it here. The main steps are easy to see but hard to do. First, divide the function domain into a suitable grid. However, what is the criteria of suitable? It is connected with the currency and the tolerance. You can see it in next example. Then, do calculation at all the grid points. However, there are too many grid points. We use an example to explain it. For the function fx, find the minimum in the interval 0 to 2, that is the current, to at least within 0.01. Similarly, we plot it first. We can see that starting from 0, fx is decreasing to its minimum, then increase to its maximum. As picture shows, and combined with occurrency and tolerance, we divide the function domain into 201 subintervals. That is to see, we get 200 grid points. We need to calculate 200 times. By calculation, finally, we find that in all grid points, when x equals 0.93, fx has a minimum. For grid search method, 200 is just a tiny number. Therefore, we can imagine what a huge amount the calculation is. Since we have already know the two methods, why not compare them to get a better one? Of course, they have similarities. For advantages, they are both easy to understand, easy to use, and they both can apply to many areas in modern society. And for disadvantages, they both need a large amount of calculation. We have experienced it in above examples. Then, they both can be very slow, although you can use computers. Following is the comparisons of two methods. For occurrency, method of bisection search may not find all numbers p in interval a to b for which fp equals 0. We explain it using this picture. Looking at this fx curve, at point A, fa is less than 0, where at point B, fb is larger than 0. For the midpoint of interval a to b, the function value of c is less than 0, which means that the next procedure will continue in the interval c to b, and we cannot find p1 and p2, these two roots. In order to avoid such situation, we have to get the first derivative of fx to ensure that the fx is strictly increasing or strictly decreasing. For method of grid search, it can find all roots since we have used all the domain. But the value we get depends on the grid we set. The smaller grid, the more occurrent value. Variable refers to the number of variables used in the method, and stamp refers to the order of stamps of the method. For variable, method of bisection search only use one variable, where method of grid search is not limited, which means that it can use more than one variable. For stamp, the former need to calculate one by one, where the latter can calculate at the same time. Now we finish the comparisons part. We go to the application part. We all know that most mathematical methods can be used in computer science, and so does bisection search method. It can be used to find the position of a specific input value within an array sorted by key-value. You should notice that the array should be arranged in ascending or descending order, and then, in each step, the method compares the search key value with the key value of the middle element of the array. In each comparison, if case match and we find the search key value. Otherwise, there are three situations. If search k is less than middle element k, then stamps repeat on the subarray to the left of the middle element. Or if search k is larger than middle element k, then stamps repeat on the subarray to the right of the middle element. Or the remaining array to be searched is empty, and a not found indication is returned. Take an example. We want to know the position of 9 in the following array, and this array is arranged in ascending order. In first search, we can find the midpoint by calculation. Here, 24. Because 9 is less than 24, the search key is on the subarray to the left of 24. And continue the second search. Similarly, find the midpoint 9. 9 is equal to 9, hence print A2. Another example is number guessing game. Game start. The computer generates a number between 1 and 100. Then player A and player B take turns to guess the numbers. The rule is that if player P chooses the number generated, he will lose the game. It surely uses bisection search method, but there are some changes. These are not compared with midpoint, but a random number in that interval. And here is our program of number guessing game. If you are interested, you can type it down to play it. As for method of grid search, it can be used in many software programs. Here are two examples. It can not only used, but also approved. BGSM is a method based on the method of grid search. Here I just mention it. If you are interested, you can Google it. Finally is the exercise part. Here are 2 questions. Now you can pause the video and use 20 minutes to solve these questions. Okay, do you finish these 2 questions? Now you can check answers. Here are answers for question 1. These are for question 2. Okay, I have finished my tutorial video. Here are my reference list and thank you for your watching. Bye bye.